Alright, so this entire next unit that we're about to do, Unit 2, is all about solving rational equations. So Unit 1 was simplifying rational expressions. Now we're going to take those same ideas and apply them to actually solving for x. Again, we have methods that are similar to what we did in the first unit that we're going to now apply to methods of solving. So it will look familiar in some of the things that we do, but there are slight differences between simplifying and solving. So this first lesson, we're going to keep it pretty basic on solving rational equations. Let's see, so today is the So to start off, a rational equation is when you have fractions on either side of your equation, otherwise known as fractional expressions or rational expressions on either side. So we're going to start with something that should look pretty familiar. Okay, here we have a rational expression, a rational equation. This is something you might notice as a proportion. So when you have a rational expression on each side and you have just one, that's when you have a proportion, which you can do the same methods you've used before, cross multiply. So if I just make sure I remember that's in parentheses, and I cross multiply, I'll have 24 equals 5x plus 10, because I have to remember to distribute the 5 to each term. To solve, we can then subtract 10 to both sides, divide by 5, and we get 14 over 5 equals x. I want you guys to get used to improper fractions as opposed to decimals or mixed numbers, because that's what our answers need to be in. So here we have just a basic proportion, but I also want to highlight something that we don't always think about when it comes to fractions. And that is, every time we have a fraction with a variable in the denominator, we have to think about restrictions. So these are the values that x can never be because it's in the denominator. So in this rational equation, I had x plus 2 in the denominator. So I need to think about the values of x that can never happen because it will make my entire problem undefined. So because we can never have a 0 in the denominator, I'm going to take the value that's in my denominator. So if you want to make a note, denominator can never equal 0. So I take what's in my denominator, I set it equal to 0, and solve. So when I solve this, I get x equals -2. This means that x cannot equal -2 in my problem because that will make the entire thing undefined. So when it says to identify any restrictions, this would be what you have to do. Now, if we happen to get -2 as an answer, we would cross it off and it wouldn't count towards our final solution. And we'll get to one a little bit later that actually has that happen, so you can see what we would do with it. Alright, so we're going to take it up a notch from our basic proportion. And we're going to now have a fraction on the left side equaling the sum of two fractions on the right. So the first thing that I would do is look to see, can I write it as a simple proportion, a fraction on either side, so I can just cross multiply. If that's not easily doable, so in this case it's doable, but it might not be the easiest way to do it. what you could do, so this is one of our methods, is just like in the last unit, find your LCD. So if I were going to add these together or combine all these fractions, what would the common denominator be? So in looking at my denominators, I have x minus 2 and x plus 2. So those would have to become, those together would become my common denominator. So we're going to go about using the common denominator the same way we used it with complex fractions. If we multiply each fraction by the common denominator, so that means multiply this first one by x minus 2, x plus 2. And again, this would be over 1, so we're able to cross cancel. Same thing on this one, x minus 2 times x plus 2. And on the last one, x minus 2 times x plus 2. So we're using that same method we used to simplify complex, because our goal here is, again, to get rid of the denominators. So once we multiply everything by the LCD, the same way we did with complex, I'll notice that this first one has the x minus 2's cancel. So I'm going to have x minus 4 times x plus 2 left on the left side. For my next fraction, I'll have x minus 2 times x minus 2. And for my final fraction, I'll have just the x plus 2, because x plus 2 times 1 is x plus 2. So what we've done, and by multiplying everything by the LCD, just like in the complex fractions, we've gotten rid of the denominators. And so now what we can do is multiply what's left together, combine like terms, and solve for x. So on the left here, if I FOIL those together, I'll get x squared minus 2x minus 8. On the right side, I'm going to start by FOILing x minus 2 times x minus 2. And then I don't have anything to multiply at the end, so I'm just going to drop the parentheses so that I can start combining like terms. So I'm going to move everything from the left over to the right. So minus x squared plus 2x and plus 8, giving me a 0 on the left-hand side. So when I combine like terms, those cancel out. Negative 4 plus 2 is negative 2, but I also have this x over here, so that's going to end up giving me negative x. And then we have 4 plus 8 is 12, plus 2 is 16, no, 14. So now we just need to solve for x. So I'm going to add x to both sides so that I can get x by itself, and I get that x is equal to 14. So when we have fractions on either side, if there's more than one, we can employ the same method of multiplying everything by the LCD to cancel out our denominator. We do still have to consider our restrictions though. So when I look at my denominator, I have an x minus 2, so I'm going to set that equal to 0 to find a restriction. I also have an x plus 2, so I'm going to set that equal to 0 to find my other one. So when solving for x here, I'll get that x cannot equal 2 and x cannot equal negative 2. Now, did we get either of those answers as ours? No, so that means our answer is good. Now, was this the only way we could have done this problem? No. There are other ways to do it. But this to me is usually the quickest way and the one that gets rid of your fractions as soon as possible. I did want to go through at least one more, if not two, to make sure we really have it down. And we are going to do one that has this restriction playing a role in the problem. Okay, so our third example, and I want you to put a star next to this one. And the reason I want you to put a star next to it is because this question is one that I can guarantee will show up on a test or a quiz. Not this exact one, but this same exact type. So when we look at this, we do have two fractions, but we have a number that's doesn't have a denominator. Or what we would do or say is that it has a denominator of 1. So if I put a 1 underneath here, I can then say, what is my LCD? So looking at the denominators, my LCD is n minus 1. So then I can go through my process of multiplying each term by n minus 1. So when I do that, I'll have my denominator cancel, leaving me with just an n. Here there was nothing to cancel, so it'll be n times n minus 1. And over here at the very end on the right, the denominator will cancel, leaving us with just 4n minus 3. So again, we've multiplied by the LCD to get rid of our entire denominators, or all of our denominators. So just like the last one, I'm now going to multiply and combine like terms so that I can try to figure out what n is. So if I distribute the n, I'll end up with n squared minus n. Now, I didn't do it up on top, but we can do it here if you want. We can combine like terms before moving. So right here I noticed that those add up to 0. So I can cancel those so I don't have to move them unnecessarily. So I'm going to now move the 4n and the minus 3 over to the left. So minus the 4n and add the 3. So minus the 4n and add the 3. None of these over here are like terms, so I end up with n squared minus 4n plus 3 equals 0. So now this should look like something you learned back in Math 2, where we're going to factor and use that zero product property to figure out what is x, or in this case n. So if I factor, so this is double bubble, n minus 3, n minus 1. I'm going to continue this up here because I'm running out of room. Then take each of the factors and set it equal to 0. So when we solve, we get n is equal to 3 and n is equal to 1. Okay, but we haven't checked our restrictions yet because we do have a variable in the denominator. So when I come over to do my restrictions, n minus 1 equals 0. N cannot equal 1. Well, we got 1 as our answer. We're going to cross that off, and our only answer will be 3. This here is what we call extraneous, meaning it's an extra solution, but it's not one that fits our problem. And so you will have these pop up as ways to kind of catch you off if you don't check it. So make sure you're checking your restrictions so that way you don't fall into that trap. Alright, so I did want to do one more with you, and the reason I want to do this last one with you is because, again, it's similar to a test question. So when we put it up, I'm going to put a little star next to it if you want to highlight it, do something so you know, go back to this example when studying, because it is going to be similar to one that is on your test. So our last example for today is still dealing with fractions. But we're kind of going back to basics with our fractions. And it's surprising how often in going back to basics that we make little mistakes. So that's why we're going to practice this. So again, you can put a star, a highlight, an asterisk, something that'll trigger your brain to go back and study that one. All right, so first thing I'm going to do here is I'm going to try to get this, get rid of some fractions by distributing the 1/2 and distributing the 1/3, because that'll combine a couple of my fractions. So when we distribute the 1/2, we'll get 1/8x minus 1/2. When we distribute the 1/3, and make sure we distribute that negative with it, we'll have minus 1/4 x minus 1. And now over here, this is a mixed number. If we're going to be able to combine it with other fractions, we have to get it into an improper fraction. So if you don't remember how we do that, you take your denominator and you multiply it by the number in front, and then you add what it is to the numerator. So 2 times negative 3 is, actually, 2 times 3 is 6, plus 1 is 7, and it's negative, so negative 7/2. So now that we have a couple of fewer fractions, I'm now going to look for that LCD, because none of these have the same denominator, or a couple of them do. So if you want, you can combine those, but we still need to get a common denominator. So LCD between 8 to 4, now remember the denominator here is 1 and 2. The LCD would be 8. So multiply each one by 8, including this 1. So when we multiply 8 by 1/8, they'll cancel, leaving just x. 1/2 times 8 will end up giving me negative 4. 8 times 4 will give me negative 2x minus 8. And we get it equals negative 28. So now this is an equation with no fractions, something we can easily combine and solve for x. So 1 minus 2x will give me negative x. Negative 4 and 8 is negative 12. Let's see, add 12 to both sides, and that'll give us negative 16. And then divide by negative 1, so we get 16. Now again, we want to think restrictions. Do we have any variables in the denominator? So in other words, is there an x in the bottom of any of these fractions? No, there's not. So because there's no variable, so since there is no variable in the denominator, there are no restrictions. So you can leave your answer at just 16. Okay, so this entire unit, just to kind of recap, is going about how to solve equations that have fractions in them. And so just like in the last unit, we're going to explore all the different ways that this could happen. So it could be we are going to go back to negative exponents and how that changes things a little bit. We are going to have square roots again, or cubed roots. So we're going to explore all of those, so that way we can move on and don't get stumped on any of the types of problems we're going to see throughout the year. So again, highlight any questions, make any notes that you want to ask. If there's something you want me to go over again because it didn't quite make sense, please tell me, and I will be more than happy to go through any of this again in class before we start working on some problems.